Hi! I did my project on water skiing, and I chose water skiing because I learned water ski probably when I was in like 5th or 6th grade, and it took a lot of time and effort, but now I actually really enjoy it. So, you know, there's physics behind it and it's fun, and it's summertime now, so hey, why not water skiing? So, the first part of water skiing is actually taking off, and it's more difficult than it looks because there's a lot of different things going on. So you're in the water. You have, like, when I ski, I still ski with 2 skis. So you've got your 2 skis on, and you've got the rope, which is attached to the boat. Now the forces on the skier are the force of the rope, which is pulling you forward, and then you have the force of the water pushing you up, and you have the force of the earth or gravity pulling you down. And that's illustrated here in the picture. So you have the force of the rope pulling you forward, the earth pulling you down, and the water pushing you up. But the thing with the water is, as you are moving along with the boat, the water is hitting your skis at an angle, as is depicted right here. So the water will hit your skis and then it'll bounce down, which is partially how you're going to be able to stand up. So the water pushes here and then pushes up on your skis, and the water goes down. Okay, the next part of skiing is actually once you're up, because the forces are balanced. So you stand up and then you're actually skiing. So the main force there is the force of the boat on the skier, and because the boat is accelerating and you're attached to the boat, you're moving at the same speed as the boat initially. And this is because of Newton's third law, which says for every action there's an opposite but equal reaction. Okay, the next thing in water skiing is the centripetal force, and this says that there's a force that makes a path, that makes a body follow a circular path. So you have your boat right here, then you have your skier back here. In between the two is a rope, and this rope keeps the skier attached at a fixed distance regardless of like what angle they are. If they're directly behind the boat, if they're off to the right side or the left side, the skier is at a fixed position to the boat. So that means that they're not going to be like, it's a circle. The skier can make a circle around the boat pretty much, and that's what centripetal force is depicting. And centripetal force says that when an object moves on a curve, it accelerates. So you'll notice that when you're water skiing, if you're staying behind the wake of the boat, which is like the V that the engine creates, that you'll be moving at the same speed as the boat. But if you go outside the wake, then you're going to accelerate because because the centripetal force is taking place. Okay. And water skiing, you have to take safety precautions because you're in water, and the Coast Guard and everybody says you have to. So you have to wear a life jacket, and there's a lot of physics that goes into the life jackets also. Water pushes against an object with equal force to the weight that the water is displaced. So if I am in the water, then the water is pushing on me the same amount as the amount of water I displace. And the amount of water displaced is determined by an object's density, which is its mass its mass divided by its volume. Okay. More about life jackets is that buoyancy is the upward force that we need from the water to stay floating. So our body is made mostly of water, which means it has a density close to that of water, but it's not quite the same. We are more dense than water, which means we're not going to float, but this life jacket's going to help. So the additional person needs 12 additional pounds of buoyancy to stay afloat, and that is because a person's the average human density is 985 kilograms per meter squared, and water's density is 1,020 kilograms per meter squared. So what a life jacket does to account for this difference in densities that we have is the life jacket, it will hold air inside of it. And the life jacket, it traps the air, so when the life jacket's submerged in water, it's taking up more space than like its mass is.